Hey guys, it's Miss Blake here. Today we're going to be doing nonlinear equations with two variables. Alright, so the first method, we're going to still be using substitution as a method. Substitution is still plugging something in. Again, you're looking for a y equals or an x equals when you're talking about substitution. Right now we have x squared equals. I probably don't want to use that, but if I add this 1 over, then I'll have y equals. So I'm going to say x squared, I'm going to add that 1 over, and there's my y. So I'm going to go ahead and substitute that in. Every time I see a y, I'm going to plug in x squared plus 1. So we've got 4x minus, and then again, instead of y, I'm going to plug in x squared plus 1. Still equals to negative 1. So I took this, plugged it in where I saw a y. Make sure you distribute that minus sign. So we have 4x minus x squared and minus 1 equals negative 1. So what you have here is a quadratic. Right? You have an x squared, an x, and a constant. So we're going to get everything to one side. We want it to equal 0. I'm going to go ahead and get this to be a positive x squared, so I'm going to add everything over here. So we're going to add an x squared over here, have a positive x squared. We're going to subtract 4x over here, so we'll have a minus 4x. And then we're going to add 1, and that'll cancel out. So we'll have nothing left over here. We brought everything over. What do these have in common? They have an x in common, so we're going to factor it out. Factor out an x, you're left with x minus 4. Again, still equal to 0. So now you have two answers. You can have x equal to 0, or you can have x minus 4 equals 0. Add 4 to both sides, x equals 4 would be your other answer. So we're actually going to wind up with two answers here. You do have to plug them both back in. So let's plug it back in. We'll plug it back into, how about the one that we changed? Because I like that one. Y equals x squared plus 1. So y equals, we're going to plug in our 0 first. 0 squared plus 1, so y equals 1. So when x is 0, y is 1. And then we'll plug in our other one. Same equation, y equals x squared plus 1. And we're going to plug in our 4. So y equals 4 squared plus 1, which gets us 17. So when x was 4, y is 17. And those are going to be our two answers. Moving on to example 2. They still want us to use substitution. So we're going to stick with the substitution. Again, you want an x equals or a y equals. Right here, it's really easy to get x alone. Just subtract 2y from both sides. So we're going to say it's a negative 2y. That means everywhere you see an x, we're going to plug in negative 2y. So we're going to come to this bottom equation. So we have negative 2y minus 1 squared plus, and that's going to stay the same all the way to the end. Now remember, you've got to FOIL this out. This is, I'll write it to the side, negative 2y minus 1 times itself. So be careful with that. When all is said and done, so make sure you do your FOILing. You can use the area method or you can FOIL it out. But this should become 4y squared plus 4y plus 1. So FOIL it out. Negative 2y times negative 2y. Negative 2y times negative 1. Negative 1 times negative 2y. Negative 1 times negative 1. And combine like terms. Same thing here. That is y minus 1 times itself. So make sure you do all your multiplying and FOIL it out. So you should get y squared minus 2y plus 1. Still equals to 5. And we're going to combine with some like terms here. 4y's and 1y squared, 4y squareds and 1y squared makes 5y squareds. 4y's minus 2y's makes 2y. And 1 plus 1 makes 2. Again, we're running into a quadratic, so we're going to make it equal 0. Subtract that 5 from both sides. minus. So 2 minus 5 gets me negative 3. And now we can factor it. So this one's going to be one where we factor. Multiplies to 5y squared. We're going to have 5y times y to get 5y squared. Multiplies to 3. We're going to have a 3 and a 1. And there's two options. It could be a 3 here and a 1 here, which I think that is the option. But just play around with it. And then 1 has to be negative. So 5y times 1 gets me 5y. And 3 times y gets me 3y. So we want positive 5y minus 3y to get 2y. And then we can solve those 5y minus 3. So you have to have a really good background in factoring quadratics here. Add 3 to both sides and divide by 5. So we're going to leave that as a fraction. And the other one is y plus 1 equals 0. So y equals negative 1. So there's our two y terms. And we're going to go back in. I'm going to plug it into the nice x equals equation. So we have x equals negative 2y. So x equals, we'll plug in the 3/5. So I'm going to write this as 2 over 1 times 3 over 5. So x equals negative 6/5. So there's one answer. We'll write it up here. When x equals negative 6/5, y equals positive 3/5. And we'll plug it into the bottom one. X equals negative 2 times 1. So x equals negative 2. So when x equals negative 2, y was 1. And those are our two answers. Oh, I might have messed up here. Sorry, that's a negative 1. We subtracted 1 from both sides. My bad. So that's a negative 1, which makes this a negative 1, which makes this a positive 2. My bad. So that should be a positive 2 and a negative 1. Sorry about that. All right, moving on. So you can also use the addition, or we called it the elimination method. You want a variable to eliminate. I'm going to go ahead and make my y's, my y squareds eliminate. So I need them to be 6. So we're going to multiply this top row by 3 and this bottom row by negative 2. Because then we'll have a 6y squared and a minus 6y squared. So we got 9x squared plus 6y squared equals 105. And negative 8x squared minus 6y squared, that's why we did it, equals negative 96. And now we can use our addition. Sorry, it's angry. I think I was holding a button. All right, so 9x squared minus 8x squared gives me x squared equals, and then 105 minus 96 gives me 9. Remember, when you take the square root, you get two answers. X could be positive or negative 3. So we've got to use both of those. We're going to plug it in. We might as well just start with the top. So if x is positive 3, we have 3 squared, oops, that's a square, plus 2y squared equals 35. We end up getting 3 squared is 9 times 3 is 27. 2y squared equals 35. Subtract 27 from both sides. You get 8. Divide both sides by 2. You get 4. And square root it again, you get two answers, plus or minus 2. So we could have x is 3 and 2, or we could have x is 3 and negative 2. Now, when you plug in that negative answer, that negative 3, understand once you squared, it's going to become positive 9, and this is all the same problem. So understand you're still going to get plus or minus 2 as your y values. So when you have -3, you could have +2 or -2 as well. So we actually had 4 answers to that one. All right, the next one, solve. I know it's really tempting because you see the y equals. It's really tempting to use substitution, but on this one, if you substitute it, you're going to get an x to the 4th. And it's not very pretty. So we're going to go ahead and eliminate. I see x squareds here. So what I'm going to do is I'm going to, let's see, I'm going to go ahead and pull this x squared over to this side. So I'm going to subtract it. So I'm going to leave the top alone. And then I'm going to subtract that x squared. So I'm left with y squared equals -x squared plus 25. So here we have y squared plus y, which we don't do anything there. X squared minus x squared goes away. 5 and 25 make 30. Subtract that 30 over, and we're going to factor. So multiplies to get me 30, subtracts to 1y. So we have y times y gets me y squared. 6 times 5 gets me 30. And the reason I chose 6 and 5 is because when I subtract them, I'm going to get 1y. So +6 minus 5 gets me 1y. So we got y plus 6 equals 0, so y is -6. And y minus 5 equals 0, so y is 5. And then plug it back in. So we have y equals x squared plus 5. If you plug in that 5, subtract 5 from both sides, you get x equals 0. So when x is 0, y is 5. Now in the next one, when you plug it in, so we had -6 equals x squared plus 5. When you subtract 5 from both sides, you actually get an imaginary number, right? The square root of -11 is imaginary. So we're going to focus on real answers. 0, 5 is going to be our only answer here. Because again, the square root of -11 is I root 11, and we're not going to use imaginary numbers. All right, last example. So this is putting it in that real world situation. Find the length and width of a rectangle whose perimeter is 20 feet. So think about perimeter. We have 2 lengths plus 2 widths, and that should equal 20. Area, length times width equals 21. So we're going to go ahead and get length alone. So if we divide both sides by w, we can make this length equals 21 over w. So we're going to substitute it into the top equation. So 2 times length, which was 21 over w, plus 2w equals 20. So here we have 42 over w. And again, to get rid of that denominator, we're going to multiply everything by w. So that'll cancel. You're left with 42. You'll have 2w squared, and you'll have 20w. Again, we're working with quadratics here. We're going to subtract that 20w over to get 0. So we have 2w squared, we have a minus 20w, and we have a positive 42. I see those are all divisible by 2, so I'm going to go ahead and get rid of that. Divide everything by 2. And we can factor. So we'll have w, and then 7 and 3 make 21, and both negative. So my 2 answers are 7, w equals 7, and w equals 3. So now looking back to this one, length times width is 21. If your width is 7, then your length is 3. If your width is 3, then your length is 7. And that's all they want you to say. So if your width is 7, length is 3. If your length is 3, then your width is 7. And that would be your final answer here. All right. That's all for today. Get the homework done. Bye, guys.